Welcome to our brief description of angles and other important vocabulary for the trigonometric unit. On a coordinate plane, an angle may be generated by the rotation of two rays that share a fixed endpoint at the origin. One ray is called the initial side. The initial side is always fixed at the positive x-axis. So there is a ray on the positive x-axis that is called the initial side. The other ray is called the terminal side of the angle and can be rotated about the center. So that's the line in blue. An angle positioned with its vertex at the origin and its initial side along the positive x-axis is said to be in standard position. We saw this vocabulary word standard position last week when we talked about our trig functions. Next is the measure of an angle can be determined by the amount and direction of the rotation from the initial side to the terminal side. Direction is something that we have not necessarily talked about prior to this unit, but I would like to point out that angles can have positive angle measure, which means they go in a counterclockwise rotation, or an angle can have negative angle measure, which means it goes in a clockwise rotation. So one way to remember this, we know that this is quadrant 1, 2, 3, 4. Yes? If my numbers go in order, 1, 2, 3 to 4, or so on and so forth, that is counterclockwise rotation. If these numbers are going backwards, if we go to quadrant 4 first, 4, 3, 2, 1, that would be considered clockwise rotation. So if you're going into quadrant 1 first, that is a positive angle measure. If you're going into quadrant 4 first, that is a negative angle measure. When the terminal side rotates, they sometimes make more than one revolution. We can go all the way around more than once. Of course, we know an angle whose terminal side is made exactly one revolution is said to be 360 degrees. If I go all the way around this circle one time, that's 360 degrees. But I can go greater than 360 degrees. In fact, I can keep going and going and going and going like the Energizer Bunny. But every time it goes around once, that is one revolution, 2 revolutions, 3, 4, 5. Here's some practice drawing an angle in standard position. So remember, in standard position, that means my positive x-axis is going to have my initial side. So for every single one of these angles, if you want, you can go ahead and draw the initial side on the positive x-axis. For number 1, I want to go 240 degrees. Well, something we didn't necessarily touch on before that I'd like to do now is just a reminder, if I go here, the positive y-axis, I'm rotating from the x-axis to the positive y-axis. That is 90 degrees. If I rotate starting from the positive x-axis and going to the positive y-axis, that would be 180 degrees. It would make a straight line. If I were to go all the way to the negative y-axis, stop here at the negative y-axis, that would be 270 degrees. And then, of course, if I were to go all the way around, that would be back to 360. So if I wanted to draw an angle that was at 240 degrees, think about which quadrant that would be in. Quadrant 1, between 0 and 90? No. Quadrant 2, between 90 and 180? No. Quadrant 3, between 180 and 270? Yes, 240 degrees is going to be found somewhere between 180 and 270 degrees. Now, it's not going to be right in the middle, because right in the middle of 180 and 270 is 225. So it's actually going to be a little closer to 270. I notice that blue line is in the third quadrant, somewhere between 180 and 270, not right in the middle, a little closer to 270. And I do want to indicate with a curved line that I am starting at the black line, the initial side, and going around in a positive measure to the red line. Following the red line, stopping at the blue line. The black line is the initial side. The blue line is the terminal side. Now, where the red line goes is important because that indicates whether I'm measuring positive degrees or negative degrees. For example, number 2. Number 2 is negative 30 degrees. First of all, I know it's negative degrees, so that means I'm going to go into the fourth quadrant first. Negative degrees, we're going backwards. We're going clockwise. And we're going 30 degrees, so it's just a little bit. Less than half. About a third. And I do want to indicate with that red arrow that I am going backwards. Example number 3 is 450 degrees. 450 degrees is greater than 360. So that indicates to me that I have definitely gone above and beyond one rotation. So since it's greater than 360, I want to find what's called a coterminal angle. We're going to get more in depth in that in a minute, but essentially it means how much over 360 did I go? So we're going to subtract 450 from 360, and we get 90. Now, I need to indicate with the red arrow where I've gone, because if I were to draw the arrow as such. That indicates a 90-degree turn or a 90-degree angle. This angle is not 90 degrees. It's 750 degrees. So that means I need to take my red line, start at the black line, start at my initial side, and go all the way around, and then an extra 90. So that indicates that I've gone one full rotation plus 90 more. Example number 4 is very similar, except in this example, my angle measure is negative. The process is still the same. I need to find the difference between this negative 540 and 360. Now in this case, because we're talking about negative angles, all that means is we're going to start going down first. So the negative just indicates my direction. I'm going to look at the difference between the positive 450 and 360 to identify how the difference between how much past one full rotation I've gone. So the difference between 540 and 360 is, of course, 180. The negative in front just indicates the angle, the direction that I'm going. So I know I'm going to stop with my terminal side at 180 degrees. But I need to indicate that I have gone one full rotation plus 180 more. Here's a better definition for coterminal angles. If you graph 405-degree angle and a 45-degree angle in standard position on the same coordinate plane, you will notice that the terminal side of the 405-degree angle is in the same position as the terminal side of the 45-degree angle. When two angles in standard position have the same coterminal sides, they are called coterminal angles. So we are going to have a little more understanding of coterminal angles. Given these 4 examples, we are going to draw a positive and a negative angle for each of the following. Just to back up real quick, coterminal angles, if you notice the difference between coterminal angles is always going to be 360 degrees. So when you're identifying coterminal angles, you are going to add or subtract 360 degrees. So, the first example, 240 degrees. We saw in a prior example that 240 degrees was in the third quadrant, slightly closer to the negative y-axis, and since it is positive, we're going through first, second, then third quadrants. Now, if I want a coterminal angle that is positive, another way I could find that is to add 360 degrees. To get a coterminal angle, an angle that is right in line with the 240, I could keep going in a positive direction, 360 degrees, and get right back to that position. So I'm going to take 240, add 360, and get 600 degrees. 600 degrees is a positive coterminal angle with 240. To get a negative angle measure, I would subtract 360 because I want to go the opposite direction. So 240 subtract 360 will be negative 120 degrees. I would like for you to try number 2. Pause the video and complete number 2. Check yourself with number 2. Moving on to number 3. Notice that number 3 and number 4 are already negative angles. So if I were to graph number 3 at negative 45 degrees, my initial side would start at the positive x-axis. My terminal side would be halfway between the positive x-axis and the negative y-axis, aka in the 4th quadrant, because I am turning in a negative direction. Now, previously we've talked about if you want a positive angle, you add 360. If you want a negative angle, you subtract 360. But thinking about it logically, if I already have a negative angle, if I add 360, is that going to give me a positive or a negative angle? Yeah, a positive angle. That's exactly right. So we're still doing the same thing we did before. We are adding 360 degrees. Even though we have a negative angle, it's fine. Add 360. Take negative 45 plus 360. And you get 315 degrees. There is a positive coterminal angle. Well, if I subtracted 360 degrees, if I subtracted 360 degrees from negative 45, I'm going to get a larger negative number. So it doesn't matter whether your angle starts out negative or positive. If we want a coterminal angle, you can either add 360 degrees or subtract 360 degrees. Example number 4, I will start with you. Start by drawing our initial side on the positive x-axis. Let's think where our terminal side will end. First and foremost, we are going negative degrees. So we're going to go like quadrant 4, and then 3, and then 2, and then 1. We're going to head in a downward direction first. Negative 130 degrees. Would not be in the 4th quadrant. I would need to pass negative 90 degrees. But it's less than negative 180 degrees. So it's going to be somewhere in the 3rd quadrant. Somewhere in the third quadrant. And it's actually almost halfway between the negative x-axis and the negative y-axis. It is almost halfway. So there is my negative 130-degree angle. Find one positive and one negative coterminal angle. And then complete the Math Excel on angles.